So that's Andreas, and if I'm right, Sebastian, and if I'm right, because I have the code names, of course, Tamara. In their presentation, they have their real names, something like that. Okay, their presentation is actually about a tool, and we all know that we use electronic gadgets everywhere, but we're not aware about what actually the human cost is of all these things. And they are developing a tool that shows us this information, and it could probably and hopefully help us a lot in defining what things we're going to use in our daily life. I want you to give them a welcome applause. Please, go ahead.
Good morning. Thanks for getting up early and coming here. I'm really grateful for that. I'm Sebastian. This is Tamara. This is Andreas. And we are building a tool, a software tool for easy supply chain risk analysis. And I will start by talking about the background of all this, what kind of risks do we analyze and why. Andreas will talk more about how we do the analysis, and then Tamara will talk about our project, Fairtronics. So the first thing I want to do is unpack this slogan a little bit. Supply chain is basically all the steps that happen to a product before it is a product, right? It starts with resource extraction, and then somehow components are being made or assembled. And at the end, you have maybe a mobile phone or an Arduino or something like that. When you're doing supply chain, you work with supply chains, basically, you have to acknowledge that electronics production happens all around the globe. So that's a major thing that makes it complicated. Risk in the sense of social risk. So what we want to do is minimize harm that is caused to people involved in the production of electronics devices. Analysis in the sense that we compute it, so we have a computational model of what kind of harms, risks are in the supply chain of a product. And the whole thing is supposed to be easy. And easy is meant in the sense that you do not need to collect extra data. If you are designing an electronic product, the tool should work only with the data you already have. As I said, supply chains are global. Making electronics products is a global affair. Basically, anything, any product you can think of will probably involve 4 to 5 continents, such as this smartphone here, which is a pretty typical case. It basically starts with resource extraction at the blue-green dots, and resources or raw materials are located all around the globe, so they come from South America, North America, Africa, Asia, and so on. And then processing and manufacturing happens in a lot of other places. So basically, the material for any product is shipped around the globe like crazy. And the background of our work is essentially sustainability. You may have heard of this model of sustainability that is made up of 3 pillars: the social pillar, the environmental pillar, and the economic pillar. Many people associate sustainability mainly with the environmental aspect, making things ecological, not emitting too much CO2, and so on. And that sometimes leads to the social aspect of sustainability being a little bit underrepresented. Social sustainability means avoiding harm, improving people's well-being, and so on. And that is exactly the aspect that is most important to our work. So what about the social sustainability of electronic supply chains? Basically, across all the stages of a supply chain, you can find a whole huge catalog of human rights violations and other problems that are associated with the making of electronics products, from having to work in dangerous conditions, for instance, being poisoned by toxic chemicals or being harmed in, when the safety precautions are not sufficient. Being forced to work, for instance, because people are in so much debt that they need to repay. Children having to work, people not being able to form unions, having to work too many hours or not making a living wage, even though people work 10 or 12 hours or more a day. Being displaced from one's home. For instance, when mines are being established or extended, then it frequently happens that the people that have been living there are forced to move. Being discriminated against or not enjoying social security, such as being able to take time off when you are sick. For instance, in gold mining, many of these cases are well documented. Child labor happens in very, very many places. And also, you may be aware that mercury is frequently used to extract gold when gold is being mined. And of course, mercury is toxic, and sometimes safety precautions are not taken, and people get poisoned, and the environment gets poisoned. So these are just two simple examples to make it a bit more plastic. And the big picture is that the digitalization which we enjoy and celebrate here at Congress happens on the backs of the people who make these electronics. So how can we fix that? I want to go through 3 example steps, 3 puzzle pieces of the solution. The first one is that there do exist some certifications that rule out certain human rights violations. For instance, the fair trade label from bananas or coffee or whatever. And there exists a fair trade certification for gold. There also exists another certification, Fair Mind, also for gold. And these do rule out a good part of these human rights violations. There's another standard, IRMA, which is in the process of being established, which applies to more metals more materials that come from mining. But the problem with all these certifications is that they are not broadly available. So in each case, there only exist a few mines that have a certification, and most of the mines don't. So another way to put this is that there does not seem to be a huge demand for certified metals at the moment. And I think this is like one of the things that need to change. A second example is that when you are the designer of an electronic product, of course, you get to decide what goes into that product. And you make a lot of design decisions. And of course, these decisions determine what kind of raw materials are needed to build your product. So this is a fun little example. This is a DIY mobile phone. So this phone was built in a fab lab. And at the back of the phone, you see these 2 little knobs sticking out. And these little knobs are capacitors. They are aluminum capacitors because the person who built this phone did not want to use tantalum capacitors, because tantalum is well known to be associated with the whole catalog of human rights problems. Here you can very clearly see this design trade-off between making the phone a little bit thinner or avoiding the use of certain resources. Many metals can be recycled. Not all metals do get recycled because it's not always cost effective. But of course, when it's being done and when it's possible, recycling is a good way to reduce the overall amount of resources that are being extracted. Why is it not always cost effective? I think this is again partly a matter of supply and demand. When there's a larger demand for recycled metals, then it will become cost effective to recycle a larger amount of them. So the general message is there do exist alternatives, but then the question is why, why do I keep telling you there's no demand? Why is there no demand? Why do not all people, try to source their materials responsibly? And part of the answer is that electronic supply chains are very complex and very deep. This is a supply chain taken from the Naga IT project, a very nice project which is also a pioneering project in fair electronics. And they tried to build the most sustainable computer mouse possible. So they took the mouse because it's a very simple product, and they tried to map out their entire supply chain as far as possible. And you can see that even for the simple product, there's basically the supply chain chart is overwhelming. And you, as a designer or as a maker of an electronic product, you are basically at the top of the supply chain, and you kind of have to look backwards and see what your suppliers are and what are their suppliers and so on. And with this huge amount of steps, it's very difficult to know where to start. And this is where a tool comes in, and Andy will now tell you a bit more about how that works.
Okay, thank you. So yeah, we have learned now that there exist severe issues in the production of electronics devices, severe social issues. We want to do something about this.